I have a worksheet here to practice some problems for your Chapter 9 test. You should have gotten this in class, and if you didn't, you can just go out to my website, and I've got a copy of it on the website. So we have a point P, and this point P has coordinates x and y, and there are a lot of words here about a point of intersection between an angle theta and standard position, and all of these words are kind of unimportant. The important phrase in this is unit circle. Now remember, on the unit circle, the x value of a point, if you have a point and it has coordinates x and y, the x value is the cosine of theta, the y value is the sine of theta, and remember, it goes alphabetically. So on a unit circle, and that's important because the next problem is not going to be on a unit circle. So here we have point P on the unit circle. The sine of theta is the y value. It's just -4/5. And if you want the cosecant, you just flip the sign upside down. Sine and cosecants are reciprocals, so 5 over -4. The cosine is just the x value. It's just 3/5. And the secant is just the flipped upside down cosine, so we've got 5/3 for the secant. And the tangent, remember, tangent is equal to y over x, the y value being -4/5, the x value 3/5. Well, if you divide this by this number -4/5 by 3/5, those 5's are going to cancel out. So what you're just left with is a -4 over 3. And then the cotangent is flipped upside down, -3/4. So there you have sine, cosine, tangent when it's on a unit circle. It's pretty easy. It's pretty easy if you remember this rule. The next example, though, this point P is not on the unit circle. Not, because there's nothing in here that says it's on a unit circle. So this is not unit circle. That's really important. When it's not on a unit circle, what you're going to do is take that point and plot it. -3, +2. Here's that point. Connect it with the origin. Drop the perpendicular down to the x-axis, and this has gone up 2, back -3, and the hypotenuse is 2 squared plus -3 squared is equal to, we can call that R or C or whatever letter you want. So we have 4 plus 9. 4 plus 9 is 13, is R squared. So the square root of 13 is R. So we're going to label that hypotenuse with the square root of 13. Sine is opposite over hypotenuse. The cosecant is the hypotenuse over opposite. Now the instructions say express answers as fractions with rational denominators. Well, we have to rationalize this, so we have to call this 2 square root of 13 over 13 when you multiply top and bottom by the square root of 13. The cosine is adjacent over hypotenuse. So we have the adjacent is -3 and the hypotenuse is the square root of 13. Flip that upside down and you get -square root of 13 over 3. But we have to take that radical out of the denominator, so it's -3 square root of 13 all over 13. That's all you can do with that. And tangent is opposite over adjacent, so it's 2 over -3. And the cotangent is that flipped upside down, -3/2. And then you've got that problem all done. Now we have some examples of problems that are not in quadrant 1. They require a reference angle. And they require all students take chemistry to see if they're positive or not. And then they require either the trick being sine, cosine of 1, 2, 3, 3, 2, 1 all over 2, or you can do the 45, 45, 90, or the 30, 60, 90. If you want a 45, 45, 90, here's a 45, 45, 90, 1, 1, square root of 2 are the sides. If you need a 30, 60, 90, here's a 30, 60, 90, 1, the hypotenuse is 2. And the other side is the square root of 3. You can do SOHCAHTOA on those to get those values, or you can use the trick. So 135 is in quadrant 2. Cosine goes negative in quadrant 2, and the reference angle is 45, because 180 minus 135 is 45. Remember, subtract away from 180. So the negative cosine of 45, however you want to do it, is equal to negative square root of 2 over 2. The tangent of 330, well, 330 is in quadrant 4. And in quadrant 4, tangent goes negative. So we have a negative tangent, and the reference angle is 360 minus 330, which is 30 degrees. Well, the tangent of 30 degrees, I think I'll go over to here. The tangent of 30 degrees, I'll use this special triangle. It is 1 over the square root of 3. But it's negative because it's in quadrant 4. But you have to rationalize the denominator, so you have the square root of 3 over 3. Or if you want to use the trick, remember sine over cosine is tangent. Oops, we forgot our angles, 30, 45, and 60 degrees for our trick. But this tangent of 30 degrees is negative square root of 3 over 3, negative. Negative, negative. Cosecant is the reciprocal of the sine. Well, 240 is in quadrant 3, so you have to subtract 180 from 240, and you get the CSC. The cosecant of 240 minus 180 is 60 degrees. But this is the reciprocal of the sine. And all students take chemistry says in quadrant 3, only tangent is positive, so that's got to be a negative value. The cosecant will go negative in quadrant 3. Well, remember, cosecant is the hypotenuse over the opposite, because it's the reciprocal of the sine. So we're going up to the 60-degree angle in our 30, 60, 90. Oops, sorry about that. Our 60-degree angle, the hypotenuse is 2. The opposite is the square root of 3. So we have negative 2 over the square root of 3. But we can't leave that with an irrational denominator, so it's negative 2 square root of 3 over 3. The next one is the sine of negative 150. Oh, well, if the angle is negative, what you have to do is get a coterminal angle. And in order to get a coterminal angle, you have to add 360 degrees to the given negative 150. So let's see what that's going to give us. Let's take 360 and add to that a negative 150. We get 210 degrees. So the sine of 150 degrees is the same thing as the sine of 210. Exactly the same, because those are coterminal. Well, 210 is in quadrant 3, so you have to subtract 180 out, and you get the sine. 210 minus 180 is 30, but in quadrant 3, sine goes negative. And the sine of 30 degrees, square root of 1 over 2, which is a half, so you've got negative a half. Oh, this one doesn't have a radical, so what we can actually do is we can figure out in our calculator the sine of negative 150. It should take us and do a math frac on it. Should give us negative a half, just what we wanted, negative 1/2. The ones without radicals can be done on a calculator. Now what we want to do is find to the nearest minute. So remember, we have to DMS that. If we don't know the angle, remember we do second sine of 0.072. So we'll take our calculator, second sine of 0.072. Now we want to DMS that, so we're going to press second angle. Second angle, option 4, will give us a DMS version. So it looks like it's 4 degrees, 7 minutes, and 43 seconds. Well, let's write that down. 4 degrees, 7 minutes, and 43.927 seconds. Now this is greater than 30 seconds. So more than 30 seconds rounds up. So this becomes 4 degrees and 8 minutes. So our final answer here is 4 degrees and 8 minutes because the 7 minutes and 43 seconds rounds up to 8 minutes. So there's our final answer for that problem. The next one is find 2 values of theta if the cosine is negative 0.4732. So if the cosine is negative, you have 2 quadrants. Remember, all students take chemistry says cosine is negative in quadrants 2 and 3. So we're going to have a quadrant 2 answer, and we're going to have a quadrant 3 answer. What we need to do is get a reference angle. The reference angle, we do second cos of positive 0.4732. Don't put a negative into second cosine. Second cosine 0.4732. Look at it's positive. And you get a reference angle of 61.7 degrees. And let's see, we want this rounded to the nearest degree. It doesn't say so, but let's round it to 62 degrees. So the reference angle is equal to 62 degrees. Well, in quadrant 2, we do 180 minus the reference angle. That's what theta is, equal to. So 180 minus the 62 reference angle will give us 118 degrees. So theta is 118 in quadrant 2. Quadrant 3, theta is equal to 180 plus the reference angle. So 180 plus 62 will give us 242 degrees. So there's our 2 answers for question number 5. A lot of work. Now we want a cosecant of an angle rounded to 4 decimal places. Well, cosecant is 1 over the sine. So we're going to do 1 over the sine of 55 degrees, 15 minutes and 32 seconds in the calculator. And remember, there's some buttons you have to press to get these. So 1 divided by the sine of. Now 55 degrees, 55, second apps is angle, option 1 is degrees. 15 minutes, second angle, option 2. And 32 seconds. Now seconds is in a weird place. It's not in second angle. It's actually, if you look above the plus sign on the calculator, you can see those 2 seconds right here. So what you do is alpha plus. So alpha plus will give you seconds. Alpha plus. And let's see what this is. 1.2169. You look at the 3 does not round that 9 up. So let's write this whole thing out and then I'll show you we should round it. 1.216936804 is what our calculator says. 216936804. But to 4 decimal places, you look at the 3. So it's 1.2169 rounded correctly. And the last one, what we have is a picture with a unit circle. That's important that this is a unit circle because a unit circle has a radius equal to 1. And remember, the center is at 0, 0. So if the radius is equal to 1, the distance between this O and this B is equal to 1 because that's the radius. Okay? Now we have a cosine of theta. Well, we have this line right here called OA. We have this line right here which is called AB. So this side of the right triangle, OA, according to this angle theta, OA is the adjacent side to angle theta, OA is. AB is from this angle theta the opposite side. And the hypotenuse is OB. So OB equals the hypotenuse, which is equal to 1 because it's a unit circle. So what they want to know is, what is the cosine of theta? Well, the cosine of theta is equal to adjacent over hypotenuse, says SOHCAHTOA, right? Adjacent over hypotenuse. So we want the adjacent, which is OA, divided by the hypotenuse, which is OB. So the cosine of theta, adjacent over hypotenuse, and that is equal to OA over 1. OA over 1 is OA. I guess I'll put a line over the top of it. So the answer would be letter D. If they wanted the sine of theta, that's equal to the opposite over the hypotenuse. Oops. The opposite over hypotenuse. So that would be AB over 1. Which is AB. That's if they wanted the sine, but they don't. They want the cosine. The cosine is OA. The sine is AB. And that's the end of this video.